So next on the inspection and testing series, we are going to be looking at low voltage motor control centers, the MCC. So as usual, we are going to be looking at two different types of test and inspection: the visual and mechanical test and the electrical test that we can carry out on the MCC. So we are going to be looking at first the visual and the mechanical inspection. So what we want to do is to look at the nameplate information, okay, wherever you have them in the MCC itself. So look at the nameplate information and then try to compare it with what was specified or what is specified, and or the drawings, the electrical drawings, the single line diagram or whatever drawings that you have for that installation. So what you will be looking at, they are basically the operating voltage, the bus current, okay, and the feeder current also. So you want to see that all of this actually matches what is specified. Then you can also look at it as against what you have on the drawings. Okay, so let's assume this particular MCC now. This MCC, of course, you see that the bus voltage is about 480 volts. 480 volts. Then the bus current too, you still look at it such that you want to ascertain that the bus current will be able to withstand or carry all the loads that will be attached to that particular bus, and each of these feeders will be able to carry the load that is attached to each of them. So those are the things that you look out for when you are trying to ascertain that that particular MCC meets the requirement or meet what was specified. So you also look at the physical and mechanical condition. Check that all the hold down bolts, the anchorage, they are all firmly established or firmly tightened, and you also check to see that the unit is clean, very neat. And then the grounding, you also want to check that it is firm, and all the cubicle covers, you want to see that they are properly aligned. Okay, then you check to see too, like we said earlier, that the unit is clean. If it is not clean, you can use the vacuum cleaner or low pressure air blower to actually clean them up, or you can use the cleaning method that is specified by either the equipment manufacturer or your establishment. So the contactors like this too, you look at them, look out for signs of high resistance, like we said before. If there are any whitish deposit at any of those terminals, those are signs of high resistance, those metal oxides. Then you manually depress the contact to see that it is moving, to confirm that it is moving freely. Verify the mechanical operation. Aside depressing it, you can also send the required signal, okay, to the operating coil, the contactor coil, to close it. If it is 12, 120, 48 volts, okay, that is needed, you can supply that one to that amount of voltage to see how the contactor will operate. So if the contactor is big enough and you can access the contact, you can open it up and access the contact, then you want to also check the contact gap when it is closed to see that it meets what was specified or the recommendation of your manufacturer. And then you also check for alignment, that the contact they are aligned when close. If they are not aligned, that will invariably reduce the cross-sectional area at that particular point, and that can be a source of problem in the course of operations. So the contact pressure too, you also need to check it to verify that it meets the manufacturer's specification. So if it does not, you can adjust to ensure that the contact pressure is as required. All the protections too, you will look at them, the fuses, all the fuses, check for signs of high resistances on all of these fuses, okay, because those ones will be a clear indication of developing problems. The bolted electrical connections, you can check for resistances with the milliohm meter. Okay, on this meter now, you can switch to the milliohm test range. So with that, you can check the resistances on all of these bolted connections. So how you do it is that you can place one of the probe here and place the other here, okay? That gives you the resistance between these both and that particular connection. So all of those will tell you if resistances are building up. If you saw that they are building up, because you want to have as close as possible to zero. So if something is building up, you can open up and clean and then tighten back. You can do the same on all of the terminals, okay, to see that resistances are not building up. Okay, so those are some of the things that you do. But as a guide, when you look at the MCC, when you open up the door, you look at it, you want to look out for signs of high resistance, like we said before. Look for signs of discolorations and what have you. Okay, those are signs of heating, and so you can, since you cannot just be going from one terminal connections to the other, you can just use that to as a guide to know which particular terminal to actually test to ascertain that the terminal is firm. So you can also check if all of these terminals, they are tight enough, all of them. You want to be sure that they are tight, okay? You have to torque it to the level that is specified either by your facility or the manufacturer of the MCC. So when you attain that torque level, then you can actually stop and leave it. So if you don't have either manufacturer's recommendation or that specification from your facility, you can use this as a guide, okay? So these are the torque values for different grades of boats, okay? So if you say maybe this boat now is a 1/4 inch and it's grade 7. So if it's a 1/4 inch, grade 7, this is the torque that you should apply, 8 pound-feet. Okay, if it is 1/2, this is the torque level that you should apply. So you want to be sure that all the bolted joints, they are properly torqued, so that they will not have loose joints that will eventually lead to partial contact and arcing and hot spot on the facility. So we can also perform thermographic survey. We use the infrared camera to look at the equipment, and then that's when it is opened up. And remember, for us to perform this thermographic survey, it means that the unit must be loaded and allowed to work for some time, so that all the components will be heated up. So it is only then that we can perform that survey. So remember, as current is flowing through all of these are resistive materials, the cables, all these joints, okay? Some heats are dissipated on all of these points. So the ones that are beyond what is normal is what we're actually looking for, and those are the things that we call the hot spots. So this is an example of what we are talking about. So you see on this from this fuse holder to the breaker, you see that we have a loose connection here. That is why you are seeing this hot spot. Okay, and you look at the temperature gradient. So you can carry out thermographic survey on the unit when it is under operations.